Reject.
Hey everyone, I am Ashley, and I am from Queens, actually, a neighborhood called Ridgewood, 2 blocks over from Brooklyn. I actually walk between the border every day. I have some slides here if you'd like to follow along. I recommend writing it down just because I'm about to quote a lot of people. And so the reading list for this is well documented in the slides, and I suggest that you check it out. So yeah, hi. I'm AG Dubs. You might know me from Twitter, where I'm very prolific. I don't recommend you follow me. I always apologize when I hear that happen, so wouldn't do it. So I'm from the United States, but I like to say that these are more of my red, white, and blue. I took these pictures when I was in Cologne. This is actually my second trip to Germany this month, which is pretty cool because I really, really, really like it here. This is something I tweeted. You guys are really awesome, and I really, really dig it. I am a software engineer at the Mozilla Foundation, and you guys might have gone upstairs. If you haven't, check it out. And at the end of this talk, there's a chance that you might be able to get some swag from them. They've got some really cool swag, and I have some for you. All right, so at the Mozilla Foundation, a lot of people don't really know exactly what we do. But the way we talk about our mission is that we want to foster universal open web literacy. And so that's kind of a mouthful, but the idea is that we really want people to be ethical consumers and creators on the web. And that can be a lot, and I'm not going to really dive into almost any of that, but it's a cause that's important to me. Instead, what I'm going to say is, for me, this means I like to think about thinking, especially the type of thinking that happens when people write code. And this kind of idea of mine, my goal, leads me to do projects like this, where I take the idea of how people take things apart and try and create new learning tools for them. And you're going to hear throughout this talk that I care a lot about learning tools, and I actually kind of think everything is a learning tool. So, what's my talk about? Who knows? Maybe we should just talk about cows in space, right? That's why you guys are here, right? To hear about cows in space? No? All right, well, so some people have talked about art, maybe. We could talk about art. This is some cool art that I found on the internet, full of cool art. But yeah, maybe we'll talk about JavaScript, right? JavaScript. And maybe in more particular, we'll talk about ES6, right? ES6. All right, but what you're going to find, and hopefully this doesn't disappoint you, but this talk is about a lot more than ES6. And so I'm going to start off by talking about the idea of abstraction. All right, cows in space, though. Maintain that. So this wouldn't be a good talk if I didn't quote Dijkstra, right? This is what, again, a good computer scientist would say. And here he defines abstraction. He says, the effective exploitation of his, kind of a bad pronoun, let's say their, powers of abstraction must be regarded as one of the most vital activities of a competent programmer. I didn't turn my phone off. Whoops. All right, so again, what we're seeing here, right, is that when we are doing programming, in its most fundamental, we are abstracting. So the abstraction principle is defined by Benjamin C. Pierce in one of his most foundational books called Types and Programming Languages. And if you haven't read it, you should check it out. But here he says, each significant piece of functionality in a program should be implemented in just one place in the source code. Where similar functions are carried out by distinct pieces of code, it is generally beneficial to combine them into one by abstracting out the varying parts. And this should be something that we're probably really familiar with as developers. For me, this is actually the joy of developing. I love refactoring things. I love this feeling of abstraction. But I want to take this idea and take it a step further. I want to get a little bit maybe more academic or theoretical with it. And so to do that, I obviously went to Wikipedia, which is definitely the academic source. Here it says, abstraction tries to factor out details from a common pattern so that programmers can work close to the level of human thought. Pause on that. Close to the level of human thought. We're going to come back to this, but that's pretty questionable. All right, so work close to the level of human thought, leaving out details which matter in practice, but are immaterial to the problem being solved. We're going to flag that too. immaterial to the problem being solved. We've got danger, danger. All right, keep this in mind as we continue. All right, so another little anecdote. I was the lead instructor at a boot camp program in Brooklyn. And if you have questions about boot camps, I understand. But this one was awesome. Basically, we took people who had never programmed before, but also were unemployed. So you had to meet a certain criteria. And then over the 6 months, we taught them to become developers, and we also got them jobs. And so this was a really, really great program, and it's still funded today. It's called the New York City Web Development Fellowship. But more important, I think, is that this is really where I began to understand that teaching was one of the fundamental skills that a developer needs. And so about a week before I was going to start, I was at a Ruby user group with the dean of the school, and he was talking about how great Ruby is as a development language. It was designed to be read as if it was spoken by a human being. Consequently, it is in English, and this was by a Japanese person, which is extremely complicated. But either way, what he said was, he's like, look at this Ruby each loop. Even your mom could understand that. Sidebar? That's not okay. Moms are smart and cool. Do not be rude. All right. So he was looking at this, and he was saying, oh, Ruby is so great. And though you might be getting the sinking suspicion that I don't agree with him, I will say that at the core, he had a really important thing to say. All right? JavaScript, maybe too much punctuation. He is saying programs must be written for people to read, and only incidentally for machines to execute. And this is a really important thing to understand. All right? The people who are interfacing with your code are primarily people. The computers involved are kind of over here. The people maintaining it, the people using it, the people writing it. All right? They are the people interacting, and we have to realize that they are not computers. But the idea of people being able to read something is tough. This is my door in Queens, and you can see here I wrote some notes. And then you can see down here the UPS person saying, nope, we missed you. We could not open the door. So again, understanding what the level of human thought is, what people can read and understand, is a tricky thing. So another anecdote. And as you may have guessed, I am not going to come out on Ruby's side here. So I was sitting at my computer, and my assistant instructor was sitting in front of the class, and he was teaching iteration. All right? Iteration is hard for beginners, and I could hear just through the one side of my headphones, it was not going well at all. And this has been going on for a while. And so if any of you guys know me, I decided to do something bold, and that's quite in my nature. And so what I did is I interrupted the class, and I said, hey, I'd like you for a second to ignore all the Ruby you just learned. This probably shouldn't be hard because you're extremely irritated and frustrated with it right now. And then what I'm going to do is I'm going to teach you iteration using a language you don't know. And they're like, that sounds like a bad idea. And I'm like, I know. But just let me try. This is already kind of terrible. Let's just roll with it. And so that's exactly what I did. And what I'd like to point out here is we understand that the concept of iteration is really three concepts: state, condition, increment. In that Ruby, that's all hidden away inside that keyword each. But in the JavaScript, I can point to it right there. Because it was exposed by the syntax, the developers that I was teaching were able to see that, and they could feel more control over it. All right? It exposed the underlying concepts that the abstraction hid away. And as experienced developers, we love that it's hidden away, but beginners hate it. It's very, very confusing. It's this idea of magic, which sometimes we think is good for beginners, but it turns out that it's not. All right, so my secret physicist boyfriend, Richard Feynman, has something to say about this a bit. He says, the real problem in speech is not precise language. The problem is clear language. It is really quite impossible to say anything with absolute precision unless that thing is so abstracted from the real world as to not represent any real thing. And so remember, with Ruby, we were trying to be real. We were trying to be human language, all right? And so we have these kinds of dichotomies that we run into. The desire to be precise, but also the desire to be clear. And at the same time, we also want to be abstract because we don't want to be writing out everything. But there's also a desire to map things towards reality so they're easier to reason about. All right? And so Pablo Picasso kind of leads us in a direction. He says, there is no abstract art. You must always start with something. Afterward, you can remove all traces of reality. So we kind of have an origin problem here. When we're designing programming languages, where do we start on the edges of these dichotomies? All right? This is my favorite slide from every conference talk ever. You may have seen it already. But what I want to imply is with programming languages, we're often doing this to our developers. All right? So if you can't read it, it says how to draw an owl. Draw some circles. Draw the rest of the fucking owl. That is the only curse word in this talk, unless I mess up. All right. So what we need to understand is both of these instructions and the instructions themselves are terrible. This is no good. All right. We're in this kind of lock. All right. And this is from Brooklyn, not Queens. So you can kind of be right. All right. We're stuck here. And so hopefully some of you got the reference, the clickbaitiness of my title, which is I'm going to be walking you through a little bit of some Carl Sagan. All right? And he says, when we're doing this, we need to think about thinking. All right? And for him, he says, the journey starts here. So let's talk about cows in space, right? Yeah, you guys remember that? Cows in space from our man Pablo Picasso, right? All right. So when we think about thinking, we need to know humans are amazing at pattern recognition. We're able to look at something like this and see this. You see it, right? Nah? Well, someone saw it and convinced everyone. Because now we have this, right? A cow in space. So we need to realize when we do this pattern recognition, all right, we recognize patterns, and when we name them, we're building our abstractions. Now, this is a very dangerous activity, because bad abstractions are probably one of the most dangerous things out there. So you might be familiar with horoscopes. The entire field of cosmology has come out of this, all right? And people spend so much time and money worrying about it. This is my horoscope from today. Maybe it's right, I don't know. Maybe I'm wrong about this being a false abstraction. I also had this one, which told me that I have nothing to worry about, you guys are charming. So we'll see how that works out, all right? So what I'm trying to say here is that when we are recognizing patterns, building abstractions, paving the cow paths, yes, I'm sticking with this metaphor, we need to be very careful, all right? Because again, bad abstractions are extremely dangerous. So now let's talk about JavaScript. All right, JavaScript has been a delightful beginning programming language because it has lacked a lot of abstractions. And that's all about to change. So, September 28th, 1980 is when JavaScript was invented. Come on, guys, really? That's not true. All right? No, that's when the show Cosmos came out. And again, this was by Carl Sagan. And the key to this show was to make available the underlying scientific concepts that ruled our universe. Make that available to the layperson. And this was extremely important. All right? And in doing so, he kind of had this catchphrase where he said, if you wish to make an apple pie from scratch, you must first invent the universe. And that is to say that to really understand what's going on in our world, understanding the fundamental concepts is extremely important. I heard this, and I was like, yes, this is the issue we have with ES6. Oh yeah, by the way, I'm not going to say the ES6 2015 thing. If you get upset about that, I don't care. All right, so this wasn't Carl Sagan, this was actually me, but I'd like to think that he supports this cause. All right, so let's talk about ES6. All right. So, as Jenna mentioned, we're going to read some of the spec now. Yay. All right, so ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. Now, relaxing is cool. I love being in Germany. I like relaxing around here, have some beers. But it's not always the right message. That's a real thing. That was the first message on the OkCupid dating app. All right? Is relaxation really the problem that JavaScript is trying to solve? Were there not enough relaxing languages out there, and so we have JavaScript now? Probably not, right? So what problem is JavaScript trying to solve? Like, what will JavaScript's legacy be when we look back at it as this like strange artifact from computer science? And that's a really heavy question, and I don't really know the answer, but I think it's going to have something to do with this. All right? And this is Laurie Voss, CTO of NPM. And he says, fundamentally, it's hard to think of a compelling reason a brand new web dev would learn 2 languages when they can just learn JavaScript. Now, that might sound pretty controversial. But they follow up by saying, if I could pick any language in the world to use on both the server and the client, it might not be JavaScript. But we don't get to pick. So let's think about that. And then we'll talk about ECMAScript 6 classes. You can't tell what I'm going to say, right? Robot there. All right. So sugar makes me sick. But like literally, it makes me sick. I have type 1 diabetes. But also, syntactic sugar makes me nervous. And syntactic sugar makes me nervous because, again, we see that syntax always obfuscates these underlying concepts. So back to the spec. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based. All right? So you might not need class syntax? All right, so this is a man who, if you take anything out of this talk, take this away. He says, remember that all models are wrong. The practical question is how wrong do they have to be to not be useful? I want to let that sit in. All right, so how wrong are we? All right, so in a class-based, object-oriented language, in general, state is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited. All right, so that might be a little bit difficult to parse if you've never read this before or really dealt with them. So I'm going to use a blog post by this guy named Regenwald, who I'm going to shout out for being awesome for saying stuff like this. He wrote a blog post called Prototypes Are Not Classes, where basically, and I won't read this to you, he explains the idea that classes are described as often as boilerplates. All right, they're blueprints. The class is the blueprint, and then we make a house from it. All right, and the house is the object. But that's not true with ES6. JavaScript classes are model homes. The idea here is that you have a model home, and you can build a house based on it, and you could leave the model home empty, but someone could move in. And in that sense, things get a little tricky. All right, so what we understand here is that we have a syntax that colloquially really obfuscates the underlying functionality. All right, and so you might be thinking that I'm saying, JavaScript classes they're objects. They're not classes, really, and maybe go home, TC39, you're drunk. This is me, and that is ginger ale. All right? But no, that's not what I'm saying at all. I'm saying this is not a hate talk in any way, shape, or form. Instead, what I'm hoping to suggest here is that we take a different perspective when we're evaluating new features for language, and that perspective is the educational one. And so I do want to mention just briefly, all right, that you could easily shut me down by being like, what even is a class? Is that even defined? And I'd be like, meet me afterwards, and we can talk about this language, which introduced them. It is super, super awesome. All right, so you might be thinking that I'm trying to wage class warfare, because I told you I was an anarchist, right? This is near my apartment here. That's a real thing. I don't even want to deal with that. All right. But instead, what I'm trying to say is that JavaScript might be trying to do a lot of things and not be any of them. If you ever go to Penn Station, This is by Madison Square Garden. It wasn't open when I took the picture, but I intend to return. Yeah, so Leslie Lamport has this amazing talk called Thinking for Programmers. And in this talk, he says, writing is nature's way of letting you know how sloppy your thinking is. And so I like to take that, and I say, teaching is nature's way of letting you know how sloppy your understanding is. How many people in here have ever taught programming? Anyone who has their hand down, do it. It is by far the only, one of the best ways to improve your programming skills. All right, so those fancy people who were talking about programming needing to be able to be read by humans, they wrote this amazing book, all right? And this was a huge change in computer science education. What they said is we need to be teaching programming concepts, not language features. When we're programming, we need to understand the activities, the abstractions that we're building, not where to put a semicolon, all right? And this is super important when we think about the idea that we have programming concepts that conflict with our syntax in JavaScript. JavaScript will be the introduction to programming concepts for an entire generation of developers, whether we like it or not. And so we need to be cognizant of this idea. And to point to Miles' talk, we need to be empathetic of our users, our JavaScript users, which is going to be people learning programming. All right? We need to be thinking about the problem that's being solved. And oftentimes, the problem that JavaScript is solving is teaching people how to program. So, to follow up that book, SICP, written by Abelson and Sussman, was this excellent person named Peter Van Roy. And so, what I'm not trying to say is that these new features are making JavaScript a terrible programming language, but something a little bit different. So he came up with this book that followed it up, and he said we need to teach programming as a unified discipline. And the way he did that in his class, all right, was to talk about programming languages as tools. Programming languages solve problems. The solutions that they provide, combined with those problems, all right, to be paradigms. And so programming languages are able to do well at one programming paradigm. Sometimes they do better at others. But there's not necessarily any bad programming language. All right, and so when he taught his classes, he would insist that people start from the beginning, to invent the universe, you might say. And what he did is he had them build an entire kernel. And he says a good way to organize a programming course is to start with a simple language and then to extend this language gradually. So I'm obviously saying, all right, we must invent the universe. When we teach programming, we need to make sure that we teach the underlying concepts before we teach the abstractions. You need to feel the pain before you know how to use that tool. All right? So obviously, every beginner should write a kernel language, right? This is a really terrible idea. No one should ever do that. Unless, yeah, just no. All right? But what we can take from this is this idea of creative extension. All right? And we actually are kind of familiar with this. All right? Ron Jeffries, who did extreme programming, I don't even know if that's a thing anymore, but this is something that we know. Always implement things when you actually need them, never when you just foresee that you need them. Don't pre-optimize, all right? So what we need to know is that prototypal inheritance is a big part of the JavaScript universe. We might think classes are useful, but they're not good for teaching, and we should not start with them, all right? This is how the apple pie gets made. Vegan-friendly metaphors. All right, so this is a TLDR slide. So if you go back, as a teacher, I always kind of like giving an index for my points. All right, but what I'm trying to say is that when we look at programming languages, we need to be empathetic to our audience, and we also need to understand that abstraction is a difficult thing for beginners. All right, and that no matter what we do with our language, when we teach, we need to start at the beginning. And now I'm going to take the last 5 minutes I have to kind of put you guys on call. Because I have this kind of kumbaya question, right? What do we even mean when we talk about programming, right? So this is one of my favorite philosophers, Martin Heidegger. And he wrote this book called What is Called Thinking, which is a very bad translation of a German that I'm not entirely sure how to pronounce either. But in it, he says this: the most thought-provoking thing in our thought-provoking time is that we are still not thinking. And you might see where I'm going with this. Because I'm going to ask, are we programming yet? When we look at the JavaScript language, remember that Dijkstra said abstraction is at the core. Do you feel like that's what you spend most of your time doing? Or is it JS lint? Is it, oh, I missed the semicolon? All right? A lot of people like to think that things that are difficult, like C++, all right, is made to be difficult to make sure that you're a good programmer and doing it right. But I don't think that's a good idea at all. All right? There are people in the academy who are taking this idea seriously and really trying to think about what programming should be, and as they design languages, designing for that. All right? And it's frustrating to me because this seems to only be happening in the academy, like MIT with Scratch. Why are we not looking at that in the industry? And I think it's something that we should be doing. So Thomas Kuhn is a philosopher and a scientist, and he wrote in this great book, The Structure of Scientific Revolutions, that scientists work from models acquired through education and through subsequent exposure to literature, often without quite knowing or needing to know what characteristics have given these models the status of community paradigms. Why do we want classes? Are we sure that's the right thing? Or did just Ruby do it, and a bunch of other people did it, and now we've decided that we need to catch up? Is that the perspective we really should be taking? So we have an awesome opportunity to more radically think about how we extend JavaScript. All right? We can think more radically about how we build the abstractions and which ones we want to build. All right? I'll leave you with this. Carl Sagan says, "It is far better to grasp the universe as it really is than to persist in delusion, however satisfying and reassuring." So I ask you, reconsider your ontology. Think about it a lot. Is this the language? Are these the abstractions that we need? And always stay a beginner. Thank you. All right. All right. I have a final thing. And I always like to take this back to my students, because as I said, this is where I've learned everything. They have built a kind of silly website called Clap for Ashley. And if you tweet at this hashtag, it will pop up and clap. But I ask, and as I mentioned the Mozilla swag before, if you could tweet something about how you're going to stay a beginner or commit yourself to teaching other beginners, we've got some really cool Mozilla bags that I will hand out to people who tweet great stuff. So again, thank you, and I'll leave this here if anybody wants to dive in, assuming that the internet works. This is always awkward because it's like no one's clapping for me. I understand, it might be broken. Okay, fine.
Reject.